Hello all, welcome back to the lecture 16 part B. In this video we are going to do some hands-on with R. So let me first start R. Start a new script. Okay, now so in this hands-on we will try to understand how the tree structured regression and decision tree and random forest works. So first, and we will do this with simulated data, and in the next video we will work with real life football data or UK Premier League data. Simulated data, simulate data. So first I need to set up a seed. Set dot seed, say let me just sample a number between 1 to 1000. Just one number is fine. 198, fine. So now once I have this, I will first decide what will be the simulation size. Capital N equal to say 200. This is my simulation sample size. This is going to our sample size. We can play with it later. So first what I'm going to do, I'm going to create sequence of number between minus pi and pi, and the out equal to n. All right, so I have created bunch of numbers between negative pi and pi with the equal interval. Okay, now I'm going to create z equal to sin x, and then also y equal to z plus r norm and mean equal to 0 and standard deviation equal to 0.3. Okay, so first, and then we are going to set up a data set. Data cbind dot data dot frame is x equal to x and equal to y. So here is my data set x and y. Okay, and now what I'm going to do, I'm going to first plot null, okay, between x lim will be x limit will be minus 3.2 to 3.2 and y lim will be, so let us first check what will be the minimum and maximum of, what is the minimum of y that we got, negative 3.4, and max is also 3.4. so we can just take y lim equal to c from maybe 3.5 to 3.5. okay, and x lab equal to x, and then y lab equal to y. All right, Next, what I'm going to do is I'm going to plot the points. Plot these points. Plot this point. Maybe I will just put a color. Okay, so color equal to red and PCH equal to 20. So I made a mistake here. I'm sorry, I should have been taken this. Actually I should take, yeah, it was a mistake. And then, so actually, yeah, it was a mistake. And minimum of y will be negative 1.52. So I can just take minus 2 to 2. Yeah, so yeah, now this is sort of okay. All right, so it's basically simple sin x but with some noise. Okay, so it's a complete non-linear relationship between x and y. Now what I'm going to do, I'm going to fit a regression line, regression line. Okay, what is that tree regression line? Yes, library R part equal to tree model equal to R part. So R part is the package. So if I just load this package and question mark R part, so it's a recursive partitioning and regression T. So it says recursive partitioning and regression trees. So it fits the regression tree structured model tilde x comma data equal to d. Okay, now well, let's not go into, I'll tell you what it is mean later, but let us try to make some plot, and then you will get a much better sense what exactly happening. So let me calculate y hat equals to predict, okay, tree mod, this is the model, and new data equal to d. All right, next let me just take the plot and then points. What I have is x comma y hat type equal to L, okay, and color equal to blue, and line width equal to 2. So let me just, so you can see that it's trying to fit through this. Okay, so now so this is the decision tree. Now if I have to fit a, say, random forest, let's try to fit random forest, and so first is my tree number, say b is 1000, and then what I'm going to do, I'm just saying for b in 1H2 capital B, what you do is first bunch of simulate id star equal to sample from 1H to n, size is say n, and replace equal to true. So maybe I'll just take a small m and m equal to maybe ceiling capital N times 0.3. Okay, so I will take less number of samples, but random samples I will take. So sort, I will just sort them. I don't need to sort actually. Why should I sort? And then d star, d underscore star equal to d id star, and then what I will do, I will just fit this tree model here, but instead of tree model star with d star. Okay, so I'll just do d star, and then I'm going to ask it as a lines. Okay, I have to do some prediction also. So I have to, after fitting, I have to do prediction tree mod star d star. Okay, and then x comma y hat and color equal to say pink. Okay, so let me just run and see what happens. Okay, there are some issues, x and y, of course. There is a issue here with this. Okay, so I have to say d star $x. Now I think this will be fine. Yeah, so it is just too many perhaps. Now if I use a little bit, and now if I put the points on this, points x comma y color equal to red and PCH equal to 20, because just kind of, yeah, so it is just too many overfitting is happening. So what we can do instead of that, we can just increase the training samples to up to maybe 7 or 0.8. Okay, maybe we can reduce the number for a while. Maybe I'm just, let me reduce the number because we can do it more and get a just sense. So let me just run it. So you will not get this, so let me just run this first. So maybe I have to just first run it as this, and then I'll just run this guy. Okay, and then if I just run the entire thing, just take the full samples, let's take that. So let me just clean it. I think it will be better if I just take a sorting, otherwise there will be Yeah, so that's why it is creating this problem. Okay, I think I made a mistake by not, if I do the sorting, then it will be better. In a sense that the color, the drawing will be better. So it is doing some random stuff because I'm not sorting it. Yeah, now you can see this is how the random forest will work. So I can just reduce it to maybe 0.3, and if I just run this entire thing for 0.3, then you will see something like this. Okay, so you will see a little bit more variability, right? And then if you just run the this guy, and so this is the decision tree. So the blue one is the decision tree, whereas the red one is the random forest tree from the random forest. Okay, so let me just quickly put those things. Tree from tree. So let me just call it here. Yeah, so now I think you can just play around with the numbers a little bit. Maybe I'll just say 500 trees, and let me just draw this first, and then I'll just run this random forest. So this is a random forest, and here is the decision tree. Okay, so now you can see how this whole thing is happening. So you got a sense that why random forest is so popular, because it's much more agile, and it's much more, it can capture the non-linear and non-monotonic behavior between the x and y than linear model. Linear model regression, you have to put the feature engineering in, you have to build in the feature engineering itself. But the decision tree and random forest has its own fine interesting behavior which capture the nonlinear behavior very nicely. So this is the advantage of using decision tree and random forest. So I hope you enjoyed the video on hands-on with the random forest. This was on the simulated dataset. In the next video, we will work on the real dataset with the football dataset from English Premier League data. So see you in the next video.